In this video, we're going to look at setting up a triple integral using spherical coordinates. So let's say we have an arbitrary function of 3 variables. We're given the solid below, and we want to set up the triple integral over that solid. Well, the way this is written, I noticed that we have a hole down here, and really what we have is a shell of a sphere. So I notice that I've got a sphere here of radius 1 that's been carved out of another sphere of radius 2. So in spherical coordinates, I can describe those two spheres as rho equals 1 and rho equals 2. So the rho values must go between 1 and 2. The other thing I noticed is that both of these spheres, both the big sphere and the small sphere, are above the xy plane. Remember that phi measures the angle from the positive z-axis downward. So if we go from the positive z-axis where phi is 0 and go down this way and hit the xy plane, that corresponds to a phi equal to pi over 2. So that gives us our bounds for our phi. Phi must go from 0 to pi over 2. Finally, if we look around how it's rotating around in the xy plane, it's going from the positive y-axis into what would be quadrant 2, and then quadrant 3, and then quadrant 4, back to the positive x-axis. Well, being along the positive y-axis, the theta is starting at pi over 2, and then if we rotate all the way around to the positive y-axis, positive x-axis in a counterclockwise fashion, that's going to make our theta go all the way around to 2 pi. So our thetas are going between pi over 2 and 2 pi. So that gives us our triple integral then is, if we do d rho, d theta, d phi, then our rho's, our innermost integral symbol here is going to go from 1 to 2. The next one, outsidemost one, is going to go from pi over 2 to 2 pi. And finally, the outside one will go from 0 to pi over 2. The differential, when we replace it, the dv, remember when we replace the differential with spherical coordinates, a rho squared sine of phi comes out. And then finally, we need to make sure that we evaluate our function at the appropriate conversion formulas. We need to replace x with rho cosine theta sine phi, y with rho sine theta sine phi, and z with rho cosine phi.